Good morning, everyone. Good morning. So today we are glad and we are actually blessed to have Ramesh Kumar sir with us. Uh, Sir is a retired scientist from VSSC. So when I was an MTech student here, my second year project I did it in VSSC, Honeycomb Product Development Division. At that time, my external guide was Ramesh Kumar sir. It happened in 2005. So after that, and my first conference paper was from Ramesh Kumar sir, and from that I could able to publish around 60 papers, and I am very glad to be in touch with my guru Ramesh sir. And if I start explaining his biodata, it may take long time. But in short, sir was a division head in Honeycomb Product Development Division. And after retirement, he was working as adjunct faculty in Barton Hill College. Then now he's taking invited talks in different places like IIT, BITS, and QSAT also. This is sir's third visit. In last visit, some of you may have witnessed the vacuum mold composite manufacturing technique. So today, sir will talk. Yes. Here, yeah, this table we did that vacuum mold composite manufacturing. So today we'll listen to this topic composite materials. All of us know about composite materials, but we are not studying in theory. Maybe 70 semester students have studied. Others are not studied it. So sir will explain you regarding that. Over to you. Sir. Thank you.
Hello. At the outset, I thank Rajesh for inviting me to deliver this talk. Why I accepted the invitation is because certain things it is difficult to know from textbooks. They don't give a straightaway method for derivation. Them roundabout method. I'll tell you where they put roundabout method and that. And the physical concept, if you know, it will be good to remember the subject. With all these things, I thought I will come and deliver a talk. And everybody will definitely get the soft copy. But I wish you must take a hard copy. Otherwise, you will not understand the subject. You have to look this way, that way. So this will give the essence of composite mechanics. If you know this much, you can attend, you can defend in any interviews and all that. Okay, let me start. Yeah. Good morning once again. Yeah. This forward and this. Let's say highlight in a light. Huh? Then, so oh, acha. No. I'm not able to see the red. Okay, doesn't matter. It doesn't work. Acha. Yeah. We'll move. First of all, we can understand from a known place. If you go to an unknown place, then only you can repeat. From an unknown place to unknown place, if you go, you cannot repeat the roadway. So what is the known thing is isotropic material. Isotropic, what is the equation? How that has been modified. That is the thing. So before that, here something I wanted to just highlight. See, 360 MPa is the for steel, whereas the specific strength, whereas for composite material 1600 MPa. But this is a pseudo number. Pseudo number means you should have an equivalent isotropic material, mean all directions. You know what we say, Ashtadik Palagar, no? Ashtadik means what? 8, this thing. So here also I just 0, 90, plus 40. No. Oh, this comes 0, 90 plus 45 minus 45. This is the layer sequence corresponding to isotropic material. So if you make this fiber into an equivalent isotropic, what will be the strength? That strength reduces to 66 unit. However, it is almost double the steel. So strength is double, weight is less. So aerospace application and even ship technology, there's no corrosion. So that way, this is very advantageous. So what you have to remember is, when compared to steel, the strength, specific strength increases double. Modulus and all that, okay, modulus is 175 units versus 30 is this side. Specific stiffness is this. Whereas strength wise, it is much. Why I put the stiffness is, if you design anything, first of all, stiffness only comes into picture. E, WL cubed by 3EI. So what is the E value corresponding to the composite for isotropic nature? So basically, these are all things you can read from your note. That is, there will not be any relative movement between the fiber and matrix, and it is over homogeneous. And what is homogeneous means what? If you take a sample from one place and if you take sample from other place, they will behave. And in the case of isotropic, in all directions, same property. Here, it is not composite. Any two orthogonal direction, it will have same property like that. So that's the orthotropic material. So layer by layer, one will be stacked. So we have here fabrication of composite in this lab. Okay, so I passed this. This is, you can read it out. So here is the very important thing. What we have seen, E is equal to, epsilon is equal to sigma by E minus nu times sigma by epsilon. See, though I have also studied, did not understand the meaning. Why two terms have come and why the terms are modified accordingly. What do you think? You cannot add a mango and a jackfruit. You can add only mango and mango. That means strain along this direction. Strain and strain only you can add in this direction. See, this is Poisson term, means this direction of the strain is in this direction. This is also in this direction. Because Poisson's means how much times if you put strain in y direction, how much it will elongate in the x direction. Then only x direction values you can add or subtract. So here you see, always in composite material, fiber direction is referred as 1 or L, longitudinal direction. And unless otherwise specified, the load direction is along the fiber direction. They mentioned. That is a default. Generally, people say, the strongest fellow, take the load. Strongest fellow, take the load. So who is strongest? Fiber is the strongest. So in this direction only we will apply the load. So generally. So now you see here, this is the first direction, fiber direction. This is second direction, transverse to it. And see the terminology, nu 2, 1 means 2 refers to load direction and 1 refers to measured direction. So epsilon 1 is equal to, minus is there, no? Minus epsilon 2, 1 into epsilon 2. So what is the strain coming in this direction when you apply load in the second direction? When you apply load in the second direction, you will measure what is the strain in the first direction. Then only you can add strain along the first direction, only you can add both. So first thing, you forget about the second term. If you forget about the second term, you can get this thing, sigma 1 by E. epsilon E1. Everybody knows. Then what is the contribution of the other direction? What happens? See, when you pull, what happens? This will shrink. So that is why negative is. So that's why negative word is given. So lateral by linear. Lateral in this direction it will shrink. And epsilon 2 is in this direction. So epsilon 1 by epsilon 2 is this Poisson ratio of mu 2 1. So that will give epsilon 1. Then you put it, substitute it here. And E epsilon 2 is nothing but stress by strain. Stress in the second direction by stress strain in the second direction. That is sigma 2 by E. So this is epsilon 1. Similarly, you just replace the number 1 by, replace 1 by the 2 and 2 with 1. That is mathematically. But physically, you think you will get that similar. And shear is equal to stress by strain is equal to Young's model. Shear stress by shear strain is the E value. E means shear modulus. So this is the thing. So strength and stiffness based analysis is generally based on stiffness based and strength based. These are two things. Where can you give me an example for strength based design? I will give you a clue. Top. Where you will hear this sound? Top. Pressure vessel. You are engineer, no? You are engineering mechanical. Not that I heard like that. Pressure. So pressure vessel, there you, if you want to design, you design based on strength based design. Whereas vibration, root of, what is the K is equal to root of K, E is, what is that? Root of K by M is the frequency, this 1 by 2 pi into root of K. So K is the stiffness, rho is the, M is the mass. So there stiffness, vibration structure or structure that undergoes vibration is very different stiffness. So stiffness based design. Here stiffness is the, we will see this. Stiffness is a fourth order tensor. What is mean by fourth order? Tensor means cos theta and theta. Fourth order means cos raised to 4. Whereas strength is equal to second order. Why second order stress? What is one step below strength is stress. Stress is equal to U resolve it. P into cos squared theta is. So that is second order tensor. So stiffness is fourth order tensor, whereas strength is second order. Because you have to design based on these things. Now, what is general typical property you should by heart it. You remove the decimal points. You remove this. You remove. You remember the 140. 140 GPa. GPa means into 10 raised to 3 MPa. MPa means Newton per millimeter square or Pascal. Newton. So MPa Newton per millimeter square into 10 raised to 3. That is 140. That is remember. ET is just very much less. Correct. What is the? This is fiber direction, and transverse fiber direction is less. Why? When you make it, you use resin. Resin doesn't have much strength. So resin in that transverse direction is low. The other direction, if two people are talking in a the strongest fellow will answer quickly. Other fellow will keep silent. So along the fiber direction, the strong fellow is fiber. Whereas the transverse direction, there is no fiber. So resin only can talk. That value is 7. Epoxy resin. You can get from here epoxy resin. And shear modulus is It's very, you see, the nature, fibrous material will have shear mode. Why? In the nature, when let's say the land, it has to grow quickly and bear the fruit. That is, it's or you say papaya or anything. So those things, when it wants to grow fast, it cannot give like a teak wood, giving strength in the middle. So it will have strength along the growing direction. Transfers to the reservoir. Similarly, shear more result. There is about 40 years before, one year for that, he was saying, Einstein has told God has never deceived. God never deceives. And Rama could break the bow, whereas nobody else would break. You see, exercise is supernatural power to do that. People will doubt, no? When many people are sitting at the time to break the bow, he could wait because the sheer modulus. See the sheer strength is 125. Tensile strength is 1000. So everybody would have applied their power to break in this direction. That is the direction of fire. Whereas sheer direction, this a mango in a tree, how you will pluck? You will not pluck like this. You will just sheer modulus is very poor. All fibrous material has very poor shear. So they will have very small 125 when compared to 6. So you apply shear, immediately can take. But when compared to applying in the fiber that on the fiber. So naturally material in of fiber, they have poor annual property or so. That is the conclusion. Now, this is the previous equation I have summarized. The previous equation is this one. This all is big. Here, epsilon 1, epsilon 2, epsilon gamma. All those things simply put it in the matrix. Then we have given by E2 is equal to U12 by U2. Using this relationship, you converted E2. E2 is what? E2 is E1 into U1. You put it here. E2 is equal to, here you can see E2 is equal to minus U12. I mean U12 divided by U1. This comes here, this goes. That's what. So I always remember that 2 into 6 is equal to 5. 4 into 3 is equal to 5. So if one number is equal to number, and here the different number is equal to all the. You put a transfer into the equal to this number. So mu1 to mu1 out of mu12 is Poisson ratio is 0.3 number. Whereas other thing is depending upon what model value is the 0.203. So here what we have to remember is this again is a matrix form. You put your inverse matrix, you take it and you take it. Finally, you will get E1 to E2. Finally, Q11, Q22, Q12, all this. Hello, I'm sorry. Welcome. ഇതേതാണ് അത് തന്നെ വേണമെന്നില്ല നോക്കുക ഡിസൈഡ് യു ഓൺലി ഡിസൈഡ് തിങ്സ് ഇത് മൈ നോളജ് വൺ ഓഫ് മൈ സ്റ്റുഡൻസ് mistakes and all that I do. Yesterday only first time I saw this paper because he asked me about some other question, so I searched it. Somebody has published with me, including my name, and so in 2010 or something. Hello. So basically, you have to by heart this. Okay. Then what happened? This is sigma represents. This is in fiber direction. So these things are generally properties of the material. Properties of material in isotropic, they put it as a D. So therefore, in the beginning, we used D as the material property. Later, in composite technology, they use bending rigidity, they use D. Therefore, people have switched over the parameter D to Q. So now this is important. See, in our strength of material, right up positive like that, there is a assumption is there, right up, bending moment and all that. Similarly here, clockwise, anti-clockwise is positive there. So this is plus theta. So now we have stress factor sigma 1 is equal to sigma 1 is equal to sigma x into cos squared theta plus sigma y into sin squared theta plus tau x into 2 sin theta cos. If we do not know this relationship, we draw more circle. Similarly, you just replace 1 into 2 into these things. And theta will be, finally you will get a matrix like now 1. You always remember 1 represents fiber direction. Always write the left side of the equation. What you like then you which one will you write the right side, which one will you write? What you know is always write the left side. What you know, always write. So here nothing is known at this stage, but it will be to move the experiment. Will do. Huh? ഇതില് ഓക്കെ ഇത് ഓണാട്ടെ. ഹലോ, can you hear me? ഇതിൽ കൂടെ വരുന്നുണ്ടോ? Coming. Okay. So what happened? You will no, oh, sorry. But this we have to show here only. There it will not work. That it will not work. This I can show only here. So when I show here, I have to look into this symbol. Okay. So I will try to do. So this we have decided. In the isotropic material property is represented as D matrix. In the case of composite, initially from known place to unknown place, we have to go. Initially, what they said, the D only we put. Later, next slide we change it because in composite D represents bending rigid. So therefore, we put the Q as it. Okay, this we talked. All this put it. We will have this way. So here you have to remember one thing. See, I always, what I try to remember when I use composite, that I tell you. I always say when there is 1 here, this is non-quantity. Why this is non-quantity? Because you will take testing. When you do testing, you use strain gauge and measure things. So you will measure strain. From the strain, you will get stress. So all in global direction. Testing is done like this only. It is not done in this direction. Global direction only. Vertical is load direction generally they put vertical direction. So X is always one refer. So this is the thing. All these things you can get from test data. Sigma X, what is it? Now we will have from material properties, so out of which we. So if you do a complicated structure and you test it, put a strain gauge and measure epsilon X from epsilon X in the load direction. From there you transform and get it using the transformation. Now here I want to tell you, please remember, this is a cube. Under shear, it will become like this. This is a cube. I don't want to put like this. I don't have. So how much is the shear? So there is a terminology called engineering strain and tensorial or vectorial strain. So this is a thing. This is vectorial strain. Engineering strain is double the thing, total thing. So this is where if you see any book in the composite, they use this half. They use a separate matrix for half and multiply. I don't use that. I directly put it like this, then multiply with 2 on both sides. So if I multiply with if you multiply with this thing, this into this plus this into this plus this into this. When you multiply this into this 2 and this 2 will get cancelled. And in this direction, multiply right hand side and left hand side with the 2. When you multiply the 2, this 2 goes out. This 2 also goes. But 2 will come. So that is the next. That is this 2 and all that. So this divided by 2 has disappeared because tensorial strain has been changed to engineering strain. So this match. So you will have epsilon 1 is equal to some relationship. So epsilon 1 is some relationship is called E epsilon. And stress to strain relationship, you will have T sigma. So these two will have a difference of 2. See here, there is 2 here, there is no 2 here in the case of stress. Whereas strain, there is no 2 here and there is 2 here. There's a change, the derivation is given. So there is a difference in the matrices. But whereas in the book and all that, no, they keep same matrices and a parameter of half one column matrix they use. Physically, this feeling appealing to me, so I use this. So sigma fiber is equal to T sigma into sigma global. Sigma of epsilon fiber is equal to P epsilon into epsilon global. Now you have stress strain relationship in global axis. Why global axis? Can anybody told? I already told the answer. Hello. I have already told the answer. Now I am asking question of what I have already told you. Why do we need stress strain relation in global axis? I already told the answer actually. Because you do testing in the vertical direction, that's the global direction, not fiber direction. If fiber is like that, you will not test like that. You always test in global direction. So in this point is not sigma global is equal to epsilon global, and this is not known. In previous slide, you will have sigma, say global fiber like this. This is also, we want a relationship between sigma global and epsilon global. Why we need like this? Because in structural testing, you put strain gauge and measure epsilon global. So that is a non-quantity. So non-quantity you have to put this side. So this we need. So this inside in earlier slides and we use the word D. Instead of D we put Q, and Q bar refers for summation of all layers. There are number of layers. So Q bar will come like that. That we will see. So sigma fiber is this relation, epsilon fiber is this relation with this thing. Now you see this thing, sigma global is equal to, see here, sigma global is equal to T sigma inverse of sigma fiber. But sigma fiber is equal to D into epsilon. So you substitute it there. So sigma global is equal to T epsilon inverse of D into epsilon fiber. Now, what is epsilon fiber? Epsilon fiber is this. We want global. This direction we want global. So substitute it here. You will get T epsilon, T sigma inverse D, T epsilon, epsilon dot. So it may be incidentally, the symmetric matrix. What is the continuum mechanics? What is the principle of continuum mechanics entering into the equation? Continuum mechanics means if I apply a force here, what is the displacement I am getting there? I will get the same displacement here if I apply the same force. This is reciprocal law. Then the medium is continuum. In a rubber sheet and all, if you do that, will not apply. So because of the continuum, this thing, the matrix becomes symmetric. Because of the symmetry nature, P sigma inverse is equal to T epsilon transpose. We see both are same. So finally, sigma global is equal to T epsilon transpose D T epsilon global. It will not stick in your mind, but when you see with after result, you see, you can definitely understand. So this is what we want, and this D we will replace with Q. And this Q of D is already we have put previous slide. This is what this is what these things Q comes as. Okay. So now you will get all the quantities. Now you have got, I have repeated the slide because we, instead of going back and showing, it will be difficult. So I have put it. Finally, if you do all those things, you will get. Now, I was teaching for MTech student, matrix inverse, matrix inverse, everything they do using their mobile phone. There all matrix multiplication, inverse, all those things is possible. So, because that is possible, these equations you don't have to really by heart or study. Here what we wanted to say is this is fourth order tensor. That only is the conclusion, fourth order. These equations you don't have to really study or by heart or refer. Instead, you do this operation using your mobile phone. They were doing all this in the mobile phone, matrix inverse and all that. Then you will get. Okay, we will move. Now we will see laminate stress strain relation. Okay, classical laminate theory is the thing. CLT, there is a classical laminate theory. A laminate is two or more two or more lamina bonded. Actually, you say laminate or lamina bonded together. Sustained relationship for kth layer is we obtain this equation. How we will come to. First of all, we know. See, if I go to a shop, I want to buy a pan piece. What you will tell? What is that? You are entering in a shop and telling, I want a pan piece. What do you will ask? Or what answer do you expect him to ask? How many meter? Single dimension. It is not two dimension. I need this much length and this much width cloth I want. You won't tell. You tell, I need 2 meter pan piece. For shirt means whatever. One dimension. Similarly, in engineering also, people wanted to put things in single dimension. This thing. So stress resultant sigma is equal to P by W into T. So the W part they remove. How much width of the cloth you want. You will only tell how much length you want. One unit is removed for easiness. So similarly, here sigma is equal to N by N is equal to stress resultant. Stress resultant is Newton per mm. In the bottom, one more mm is coming as T. So Newton per mm squared it will come. So sir, now N is equal to, because why do you want to write like this? Because we wanted to represent in single dimension. Single dimension means one dimension is avoided. So N is equal to sigma into T. That is sigma is equal to E into epsilon. It's a representative way of writing. Is equal to ET into epsilon. So ET is the one that relates, N is related to strain using E and T. E is the rigidity, stiffness, and T is the thickness. What is the difference between isotropic material and composite material? Isotropic material, you generally have one thickness. What is the thickness of the plate? Like that. Whereas in the composite, you will have n number of layers constitute this thickness C. So how you will bring into the, because of computer programming and all that, people wanted to write the equation which is more suitable for programming. So they will have this ET is represented as A, and how to calculate A1, A2, all these things. These put it in this fashion. You substitute for the n, first layer, second layer, nth layer. Here also use the word n. N is the number of layers actually. This and this don't get confused. Huh? This is stress resultant where only once we use n is the number of layers. So this is E into T. E is nothing but stiffness, D matrix. Into T is thickness. So this is the way of representing. Let us see how this equation is validated. This is programming language purpose it is written. Let us see how easy it is. See here, you have to understand the right hand rule. What is right hand? This is X. X to Y, if we go, W is the outward norm. W is the outward norm. This is the first layer, second layer, third layer. Now you put like this. These things, no book, they didn't explain this. They only simply put this figure. So Z is in the arrow mark will be in the outward direction. This is the first layer, this is second layer, third layer, textual. So in all the composite books, you see like that Z in the downward. So this is K is why we put like that 1, 2, 3, we write like 1, 2, 3. So 1 will come the top. 2 will. So if you had it been there, 1, 2, 3 will go from bottom to top. Instead, we write top to bottom. So K1, K2, K3. Layer 3 layer is there. We wanted to solve the present problem for a 3-layered thing. Plus 45, 0, minus 45. That is plus, this is plus 45, minus 45, then 0 in between. Why 0 in between? Because there is a terminology called interlaminar shear and all that. To smoothen it, 0 is put in between. That we are not discussing now. So this is what general is there. So here one layer of 45, one layer of minus 45, and 2 layers of 0 degree. So let us see, let us use this equation. First layer, K is equal to 1. Put K is equal to 1. So H1 minus H0. H1 minus H0. H1 is equal to, this is the middle, geometrical middle. Here is one layer coming. So H1 is equal to 1 mm. Have you understood that total thickness? Have you written total thickness within that? Total thickness is 4 mm. 1, 2, 3, 4. So middle layer is having 2 mm. കാണുന്നില്ല അല്ലേ? Okay. Disperse ചെയ്യണം bro. PPT? I think total time it will take. Or let's see which stage we can this slide we can stop. When I come to this slide, we'll stop. 3 slides more. Hello. 2-3 minutes. After 2-3 minutes, we'll. So, what will happen? You substitute it. So, you will get the H naught is equal to -2 because this is the middle surface, geometrical middle surface. Top minus bottom plus. So, -2 plus 2, total 4 mm thickness. Each layer is 1 mm. 0.2 means 2 mm. I have put actually in composite, nobody will put 1 mm and all composite material thickness is 0.1, 0.2 mm. I have put purposefully 1 mm for easy calculation. Decimal point we can avoid first of all. Second thing, if you have more thickness, buckling will not happen for the shell. It will fail by compression only. So because of all this thing, I have put 1 mm for sample problem. So 1 mm. So when you substitute it, you will get 1 mm here, you will get 2 mm here. So actual thickness you will get using this formula. So programming is easy in this way. So now we will see, what do you think? When you have, this is for the basic material matrix. This is already our, this equation. See here, this is E1. E1 is equal to 139 divided by 1 minus nu 1 2. That is roughly 1 only. Like that, E2 we already put earlier. The property table, if you see, I see here. See, E2 7 is put actually into Poisson's ratio. E2 is 7. See here. Here, nu 1 2 into E2. Nu 1 2 is 0.3. 0.3 into E2 is 7. 7 into 0.3 becomes this way. Like that, this is the matrix already available for 0 degree. You substitute here. How it comes? You will have Q1J. 1 means first layer. The matrix is 3 by 3. So this is 45 degree is the first layer. So thickness is 1 mm. So matrix of this thing at first layer 45. 45 degree means you have to resolve. We have got the formula that we will show it again. Like that will come. How will come? We will see once again. Bottom next slide it is there. See here. Plus 45. This is the formula we have already written there. There you substitute 45 degree. Then you will end up like this. Then you will get this Q bar. Similarly, minus 45, you will have this thing. You will end up Q bar because plus 45 minus 45 for this Q bar doesn't have much significance because even power. So even power of negative will become, you will have a positive value. Minus x whole squared, x squared. There's no minus sign. X raised to 4 again, there's no minus sign. Like that, these two things are same. then 0 degree we already got it. So if you substitute it, you will get the value Aij as this number, Newton per mm. Now Q is equal to what is Q? You forgot. So immediately we'll go back. Q is equal to A divided by thickness. A divided by thickness. So what is the total thickness? Total thickness is 4 mm. So you divide with 4, you will get Qij. So this is the matrix you will substitute. When you substitute, you will get this. Into 10 raised to 3 is there. 10 raised to 3 is there. That is what gigapascal we put here. Gigapascal. Okay. Now you go to here. With this slide we will stop. That this we will. Here, what is the idea behind this thing? You will have 1 glass of milk. You will have 1 glass of water. Mix it and take 1 glass. How much will be the milk? Hello? How much will be the milk? Half quantity. Like that, in composite, you are mixing with the layers. So what is the equivalent property? How to find out? That is why this. So equivalent property, Q is equal, these are our formula. This is rough calculation. That is, rough calculation is 4th order tensor. E naught into cos raised to 4 plus 2 times plus or minus plus 2 minus 2 is there. So 2 layers are there. So 2 into E naught, the total number of layers is 4. So divide with 4. So you will get roughly, this is rough calculation, around 78 coming. Now you do actual calculation, Q1 bar, Q and all that is there in the previous slide. This is what the Q. Substitute this value, you will get what is E1. So you are getting 80 roughly. And similarly, you will get the other property. What is the idea behind this thing? Idea behind is if I want to calculate a 0 plus 40, 0, plus 45, 0 minus 45 of 0 2 mm thickness plus 45 1 mm thickness minus 45 1 mm thickness, total 4 mm thickness. So if all put together, if you do it, what is the deflection you want to calculate? WL cubed by 3A you want to calculate it. So for that, you put E as this value, which you got it from rule CLT, classical laminate theory. Substitute it, you will get 2.3 millimeter. So 2.3 millimeter, if you want to get, you cannot get from your conventional formula. So you get equivalent property and get it. Okay, Rajesh? The next we'll see that. Okay. This is what we wanted to. Yeah. ഇതുണ്ടല്ലോ. So, dear students, now we wanted to make analysis how to do it. So, always you apply load in the vertical direction. So, that vertical direction is referred as 0-degree fiber direction. Okay, when I say 0-degree means it is in the load direction. So, the layup sequence is plus 45 minus 0 to minus 45. For which we have calculated all the constants by now. Because in previous slide we got all the stress transformations and all that made. So here in the x direction you have a n. What is mean by that? I applied a load P, so divided by 2 pi r into T will be give stress. Or in other words, I will apply stress. Stress is equal to P by A. A is equal to 2 pi r into T. The 2 pi r, I take it out. So it will become stress resultant. When you go to a shop, you will only tell one dimension. Shirt 2 meter or pan piece 1.5 meter, something like that. One dimension only say beam of unit width and all that we say, beam of unit width. Like that, it is represented in terms of N. As strain in a multi-layered composite is continuous. What is the meaning of continuous? Continuous means together. If I pull, it will come like this, elongate continuously. It is not that one layer will move forward, other layer will less movement, nothing. Move all together. That is continuous. While the stress in each layer are different. Stress in each layer is different because modulus are different. Or discontinuous. Analysis based on strain. Generally, 0-degree is assigned. Generally, 0-degree fiber direction is assigned to load direction. So from equation 2, which we have seen, n is equal to sigma into T, sigma is equal to E into epsilon. E into epsilon is nothing but A. So inverse, if you take it, epsilon is equal to inverse A into. Why we are writing A, epsilon is equal to? Because strain is continuous. Each layer, it will be strain. So suppose if you want to get stress, you multiply epsilon into modulus. You will get it. Because strain remains same in all the layers. Plus 45, minus 45, or whatever the thing, it is all same. Strain is continuous, where stress is discontinuous. So in terms of stress, strain we have taken. Now same thing we have put it here, epsilon is equal to A inverse. So the other side, earlier the epsilon, so epsilon is equal to A inverse n. So A inverse we got it from this, because last time we got A matrix. So inverse of that you take it, you will get this thing. Then what is epsilon x? Epsilon is equal to inverse of this thing is you put it in terms of star we have got. A star 1 1 this thing, A 1 2 this. So you put A 1 1 is this is A 1 1 star, this is A 2 2 star, this is A 1 2 star. So all these value you put it here. So what will happen? You will get epsilon is equal to this value, 0.0031 E minus Ne into Nx. Similarly, epsilon y is equal to this into, what will happen? This here, second, epsilon y second line it is. This is second line. So Nx into this thing. So you got it 0.002 this thing. So you got this minus, and see the beauty of the mathematics. When I elongate like this, other side will shrink. Or rather, when I shrink it, other side will expand. So this is physically we know. Mathematically also, see here minus and plus. Automatically it has come. Mathematics is correct like that. So when you compress it, it will bulge out. When you pull tension it, it will shrink. So here we have put minus sign, so you got it right. And strain is equal to tau is equal to multiplied with this thing on third term, this one, A13. A13 is this. So you put it here. The stress in the 0-degree fiber direction, sigma 1, which is under compression. So Q already obtained. This earlier we have seen. Some previous slide we got it. Like this you see here. See, this you got it. Same thing only we copied here. This one. Now, sigma 1 is equal to, maybe not the 0-degree fiber direction is parallel to x direction. Substitute E11 corresponding to fiber direction and E22 in the transverse. So you have to, your relationship is sigma 1 is equal to E1 divided by this thing. This relation already given in the text here. Just copy it. That is Q11 epsilon x, Q12 into epsilon y. So in this Q11, it is already there. You put it, and Q12 already available, you put it here. So Q11 into epsilon x. Epsilon x is 0.0012. Just now we got it. Then other one. So just substitute it, you will get sigma 1. And you similarly you will put sigma 2. That is sigma 2 is a Q12 into epsilon x. Here we have put this term Q22 into epsilon y. So when you substitute it, this thing, you will get this thing. Here you remember one thing, you wanted x and y. Here this side it is 1 and 2. So we will put in the previous slide. Please remember whether I put the fiber layer like this or like this, property does not change. Whereas strain value is in the global direction, we said. So if I put fiber like this direction strain is different. If I put like that, this, whereas modulus and stress will not change. Suppose a composite I loaded, simply because I tilted like this, fiber stress will not change. Strain will be different in the direction dependent. Along x-axis it will be different. Okay. Now you write it and follow, then you will understand. Right now when I say you will not able to catch, you take and now itself you write and study. So any interview and all that they will ask, you can answer. Sai-Hill criteria is used. Failure criteria. What is the failure criteria? The Sai-Hill, this is Sai-Hill criteria. This T is silent actually. T is silent. So Sai-Hill criteria is sigma. This is the value. What you have to observe here is plus value will have property of plus. Minus means minus value, strength value. See, you won't understand right now, but let us see. Here, if my stress is plus, then I have to take plus value. If my stress is negative, I should take this value. Here I am not putting minus and all that. Compression, compressive strength. Strength you will tell we will not say that X is equal minus of this, we will not say. Compressive stress. Similarly, here, in this, when you substitute it, so you will substitute this we already seen. Then here you have substituted sigma 1, the whole squared, all those things you put it. Then you will get sigma critical as 138.2 MPa. What is the strength property? Strength property of tensile strength is, it is under compression. The compressive property 1000. Though unidirectional value for the fiber is 1000, plus 45 minus 45, when you mix it, its strength reduces as much as 138 MPa. Value is very much less. How to calculate that only with will criteria. So it is also necessary to obtain stress in plus 45 alone. Now we have checked in 0° fiber. So plus 45 also you have to check it, what happens in that. So again the same Laeb sequence. See here you see E value, whether plus 45 or minus 45 or 0, E value does not change. Strain changes. Strain is direction dependent. The other one is fiber direction. So here you put, this is where people may make mistake. UDL value, unidirectional laminate value. So in this equation, this value, if you substitute it, you will get a value of this. This is the earlier thing, x. Epsilon x is the x direction. Now we want 45 direction. So epsilon x 45 we want, whereas we want global only. So you have to transform the strain in the 45° direction. For that, you have the transformation equation, which we have derived. This one. Put it here, and you will get the value along, because you have seen 1 and 2. Here 1, here epsilon x. Here you will have 1, 2 and also. You have to take the value. When you substitute all those things you get here and you substitute it, you will do 2 times 0. 0 is 2 times. Sigma 1 is 2 layers are there. So this thing. No, not because of that. That comes in another fashion. Just check it. Finally, you will get this value is very, very small. Therefore, shear, due to shear, it does not fail. It does not fail by shear. So that is what, here you check it, this 2 is really working or not. You have to, I don't remember now, but check it, and when you write it, you will get it. This is what I wanted to say. But light now it has come. So the conclusion is, classical laminate theory has been derived from fundamental and behavior of laminate has been discussed. Overall orthotropic property of a given laminate sequence of this thing has been determined using matrix that relates stress and strain. Thus, how to design a cantilever beam is illustrated. Following Sai-Hill theory, failure load of composite cylinder under axial mode is solved. Study is useful for the design of symmetric laminate. Here, I have not explicitly told the Laeb sequence has to be symmetric. You see, a leaf, when it is dried in the hot sun, what will happen? It bends. Leaf does not elongate and dry, or dry as it is. It will have twisting and all that. Whereas you see the hay, rise here and all, doesn't twist because it is unidirectional. Whereas a leaf fiber, which will have different directions and all, there will lines and all that you see. So that will have bending also. If you apply axial, it will have bending also. That part I have not taken. It's only symmetric only I have taken. Just I told this easy problem only I have taken. So best thing is you must write it down once. Looking at it, you don't have to by heart it. Just write it and try to get. Then you will have a grip of the subject. Otherwise, it will be confusing. And so once you, these things, people can ask, can you give me, what question they will ask? Can you give a typical unidirectional laminate properties of a fiber, say carbon fiber? So you can say 140, remember 140 GPa, 7 GPa, ET, and other thing also 6 GPa. Instead of 6, you put 7 also. So when compared to 147 and 6, doesn't have much difference. So you say what is the value? Shear modulus is how much? So that way 6 GPa. 6 means you put 7. So you have only 147.7. E1 is 140, E2 is 7, G12 is 7. So easy to remember. GPa, all are in GPa. Typical Poisson ratio 0.3. So typical value and strength value, that is important. Strength value typically you have to remember. Under axial load, it is 1600 unit. Whereas compressive, when it is compression, why the values are different? This they can ask in interview. Why a composite possesses tensile strength and compressive strength as different? Because when you fabricate a fiber, you know how it is fabricated? Petroleum product evaporates, they put evaporate and deposit on a fine boron thread. So inner will have solidification rate different than outer side. So there will be residual stress. Because of the residual compression, when you put tension, it has to overcome the compression. So the value will be more. If you apply compression, then already there is a residual compression. So value comes down. That's why tensile and compressive stresses are for fibers are different. So this is shear modulus is shear is independent of sign. So that remains same. This is what I want to tell you. Unless you work out and write it once for all, you collect the note. Otherwise, you will forget it. This class will have no value. They will give you soft copy. I suggest soft copy. Okay, you keep soft copy, but hard copy only you will look. Soft copy, if you look, you will not understand. This side, that side, and you cannot turn. And you take a handout. എത്ര slide ഉണ്ട്? 24. So in one slide, 2 or something, it will be less only. So that if you take it, it will be useful. Okay, in aircraft and all that, nowadays in aircraft, 70% of metallic things, they are replaced with the composites. Density is 1.7 gram per cc. Aluminum is 2.7 gram per cc. So weight reduction is the strength is very high. So the thickness, the required thickness will be less. So it will be lightweight. So there and easy to repair also. Metal means when crack falls means you cannot. Aluminum welding is a different technique that they don't do. Any aircraft they don't go for salvaging because life is very important. So salvaging and they will replace the thing only. So composite means it is easy to replace. In repairing also Australia, in India, in world level, Australians do repair scheme. I have done one, I have sent one slide to Rajesh. In my car, dicky area, there were so many, because of stone hitting and all that, in the dicky, the hole was there. some places rusted and cracked. So what I did, I put a glass cloth with the epoxy resin mixing. And first position, I tell you the design is like that. What is the surface area of the dicky car? Whether I have sent it to him, Rajesh. In my, I don't know whether my mobile has, I deleted, I think. ഇതെടുത്ത് മൊബൈൽ എടുത്ത് നിങ്ങൾക്ക് കാണിക്കാൻ പറ്റുമോ ഇവർക്ക് ഇത് വഴി എങ്ങാണോ അതിനെ നിങ്ങൾ തന്നെ ഞാനത് ഡിലീറ്റ് ചെയ്തോ എന്ന് എനിക്കറിയത്തില്ല പുള്ളിക്കാരനെ അയച്ചു കൊടുത്തെന്ന് തോന്നുന്നു രാജേഷിന് Okay, the thing is very simple. The dicky, car dicky area where the big tire is there, no? Just bigger than that. So, what is the area? Thickness of the fiber is thickness of the glass fiber cloth is 0.2 millimeter. So, you will get the volume. And volume fraction is 70%. So, if the volume of that comes around 100 cc, then you have to get 70 cc. That for the total thing will be 70 cc only it will come with the mixture. And the other 30 cc will be resin. So resin will be balanced this. So that much quantity you pour and make it. Something I did and I used in my car, I put it that way. The photo is available with Rajesh. So this is startup wise, you know, that last time we demonstrated here in this room, in this table, composite product. A very good startup actually it can have. Composite product you can have. Now what Rajesh wanted is a pseudospherical shell. Note undallo alle? Note. So I tell you what is pseudospherical shell. He wanted me to discuss that. You know, when you see a boy, how will you judge? Because I don't want people to see a girl. Boy, no problem. How will you judge the health? He is brave. How will you say? I can easily say he will not have much belly. If a person has belly, will not have much strength. Belly means positive gauge curvature. And belly inside like this, like Eiffel Tower type of thing, negative gauge curvature. So anything that is having negative gauge curvature will have more strength in human beings. I'm telling the human. So Eiffel Tower is negative gauge curvature. There is a tree available commonly in Kerala. The tree, you know, which goes like this. It will not grow in a straight way. It will go in a curved way of this thing. So negative curvature way only the tree grows. So these are all the things. Anybody wanted some fundamental doubt? So what I wanted to say, the subject, why I have taken interest is you cannot learn that easily from textbooks. Textbooks it gives unwanted things and all that, very difficult to learn. This is directly straight away. So you can write it in a simplified way 1 or 2 times. Or when you go for an interview, you can look into it like that. So you should have a copy of the handout. That is one request. If you tell them, they will give. Pseudospherical shell in a note whether I have sent I choose Rajesh Nil Ratri. Open Jabatile.
I have sent it. എൻ്റെ ഇതിൽ നിന്ന് ഓപ്പൺ സെൻഡ് മെയിലിൽ നിന്ന് അയക്കാം അല്ലേ? എൻ്റെ ഇതിൽ നിന്ന് അയക്കാമല്ലോ, എൻ്റെ നിന്ന് ഓപ്പൺ ചെയ്യാമല്ലോ. അപ്പോൾ ഐ വിൽ ലോഗ് ഇൻ. സോ വാട്ട് ഈസ് sudo space? Ideally design. ഇത് കഴിഞ്ഞല്ലോ, അപ്പൊ ഇതിന് അടുത്ത ഇല്ലല്ലോ, ഇത് ക്ലോസ് ചെയ്തിട്ട് അടുത്ത പേപ്പർ അടുത്ത എടുക്കുക, ഏതെങ്കിലും ഒന്ന് എടുക്കുക. ഒരെണ്ണം ഇന്നലെ ഞാൻ അയച്ചത് എനിക്ക് ഓപ്പൺ ചെയ്യാൻ പറ്റിയില്ല ഇതിനകത്ത്, കാരണം അഡോബിന്റെ എന്തോ ഒരു അടുത്ത് ഇത് ക്ലോസ് ചെയ്തിട്ട് അടുത്ത ഓപ്പൺ ചെയ്യുക. ഇതെന്താ താഴോട്ട് വന്നേ? ഇത് എന്ത് താഴോട്ട് വന്നേ? ഇത് എൻ്റെ ഫോർമുലയൊക്കെയാണ്. ജസ്റ്റ് ചുമ്മാ ഒന്ന് പോയിച്ചാൽ മതി. ജസ്റ്റ് സ്കാൻ ചെയ്തേക്ക് എന്തൊക്കെ ഉണ്ടാ കണ്ടില്ലേ? ഇതുണ്ട്. ഇതുപോലത്തെ ഒരു കെട്ടിടം നിങ്ങളുടെ ഇവിടെ ഉണ്ട്. ഇങ്ങനെ ഇത് വർക്ക് ചെയ്യുമോ ഇവിടെ? ഇതുപോലെ ഒരെണ്ണം ഇവിടുത്തെ എത്ര ഇത് വളരെ ഷാർപ്പായിരിക്കുന്നു. കുറച്ചുകൂടി പോട്ടെ, താഴോട്ട് പോട്ടെ. ഇങ്ങനത്തെ ഷേപ്പിൻ്റെ ആക്സിസ് ഓഫ് റൊട്ടേഷൻ്റെ ആ ഒരു ലൈൻ ഉണ്ടല്ലോ, ആ ലൈൻ ക്രിയേറ്റ് ചെയ്യുന്നതിൻ്റെ ഇക്വേഷനൊക്കെ അതിനകത്തുണ്ട്. നെക്സ്റ്റ് പോട്ടെ, ഫിഗർ കാണിക്കാനായി ഇതൊക്കെയാണ് അതിന് എടുത്തത്. നെക്സ്റ്റ് ഇതുപോലെയാണ് അതിൻ്റെ ഡിഫറൻസ് ഒക്കെ വരുന്നത്. നെക്സ്റ്റ് പോട്ടെ. ഈ സമയത്ത് അവർ കൂടുതൽ ഡീറ്റെയിൽ ഒന്നും നമുക്ക് വേണ്ട. ഷേപ്പൊക്കെ എങ്ങനെ ഉണ്ട് അതുപോലെ തന്നെ. ഓക്കെ, മതി, ഇത്രേ ഉള്ളൂ. ഇത്ര അത് ക്ലോസ് ചെയ്തേക്ക്. ഇനി അടുത്ത് അതിൻ്റെ ഫൈബർ പാത്തൊക്കെ വേറെ സ്ട്രെയിറ്റ് ആയിട്ടല്ല, ഇങ്ങനെ ഇറ്റ് വിൽ ഹാവ് സെപ്പറേറ്റ് പാത്ത്. ആ പാത്തിൽ ഫൈബർ വെച്ചാൽ ദർ വിൽ നോട്ട് ബി എനി ബെൻഡിങ്, ആൾ വിൽ ബി മെംബ്രെയിൻ ആയിരിക്കും. ദാറ്റ് ഇസ് അഡ്വാൻറ്റേജ്. പക്ഷെ നമുക്കങ്ങനെ പ്രാക്ടിക്കലി ചെയ്യാൻ വലിയ ബുദ്ധിമുട്ടാണ്. അറ്റ്ലീസ്റ്റ് ബേസിക് സ്ട്രക്ചറിൻ്റെ ഇത് നെഗറ്റീവ് ഗോസ് കർവേച്ചറിൻ്റെ പുറത്ത് അനാലിസിസ് ഓഫ് കോമ്പോസിറ്റ് സ്ട്രക്ചേഴ്സ്. അവിടെ അടുത്തത് ഇതിനകത്ത് ഫിഗർ ഉണ്ടെന്ന് തോന്നുന്നില്ല. ഇതുപോലെയൊക്കെയാണ് അത് കോമ്പോസിറ്റിൽ. Yesterday only I saw this paper first time. They included my name. I did not review. Whatever they put. See the curve, you see? This curve, you see? Just a minute. This curve only you generate by equation. Then axis of rotation you would give. So you will get this pseudocircle. Next. Okay, now figures. Figure ഇപ്പോൾ ഇവിടെ നമ്മൾ കാണിക്കാൻ ആഗ്രഹിക്കുന്നുള്ളൂ. ഓക്കെ, ദാറ്റ്സ് ഓൾ. ഇനി വേറെ ഒരെണ്ണം കൂടെ ഉണ്ടോ? ഒരു ന്യൂമറിക്കൽ നമ്പർ പോലത്തെ ഫയലുണ്ടോ? പറ്റുന്നില്ലേ? അതെന്താ അത്? അഡോബ് ചോദിക്കുന്നോ? ഞാനും നോക്കിയപ്പോൾ ഓപ്പൺ ചെയ്യാൻ പറ്റിയില്ല. ബേസിക്കലി if you make a structure, pseudospherical structure, and load it and see, even aluminum is also okay, because fiber and all that we may not, at least this shape wise one conical structure of aluminum. Same thing with the pseudospherical thing. You will see the difference in the load bearing. Or no? Let me close it. Okay. So basically, in launch vehicle, no, interstage structures are made Singer stiffened composite, sandwich composite, all those things we put it for. The pressure vessel means filament wound pressure vessel. All those things are there. We started at 10:30, now it's 12:15, doesn't matter. Any doubt is there, you can ask. You must take the printout and try to see it. It is not that easily it will stick to your mind. You have to refer and this thing. You are in which year, students? Second year, huh? Which year is your engineering? Huh? Oh, MTech, huh? All people are MTech. Huh? BTech. Which year? First year. Huh? Oh, I see. So keep it with you so that you will understand. You should have an exposure. In simple sentence, you can say that composite material will have different modulus in different direction. At least that much anybody can say. He wanted to show something, something you might have made or something. Last time, whatever have come, they made same thing you attempted. You mean here they attempted and something they want to show. I don't know. Huh? Last time. ഇവിടെ എന്താ ശേഷം അത് ഞാൻ ചെയ്തതല്ലേ, നിങ്ങൾ ചെയ്തതിന്റെ കാണിക്കുമെന്ന് പറഞ്ഞായിരുന്നു. ചെയ്തായിരുന്നോ? അല്ല, ഇവിടെ ചെയ്ത സാധനം നിങ്ങൾ വീണ്ടും ഇവിടെ റിപ്പീറ്റ് ചെയ്തോ? If you have any doubt like that. Here first year will have same subject, common for all discipline, no? ഞങ്ങളെ സ്യൂഡോസ്ഫെറിക്കലിന്റെ എല്ലാം എടുത്തു കാണിച്ചു ഓരോന്നിന്റെ ഇത്. നിങ്ങൾക്ക് അയച്ച ഫയൽ ഓപ്പൺ ചെയ്ത്. അപ്പോൾ അവരിത് നിങ്ങളുടെ ഇവിടെ ഒരു കെട്ടിടം പോലെ ഉണ്ട്, ഇങ്ങനത്തെ ഒരു കെട്ടിടം ഇത്. പക്ഷെ അതിന് മേളിൽ ലോഡില്ല. ഇത് ലോഡ് ബെയറിംഗ് സ്ട്രക്ചറാണല്ലോ. അപ്പം ഞാൻ പറയായിരുന്നു, ഒരു അലൂമിനിയത്തിന്റെ you may make a cone, aluminum cone, and then make another pseudospherical. What is the problem? Problem is the contour mold you need, over which only you can wrap aluminum.
Sorry,
hyperbolic.
കൂളിംഗ് ടവർ ഒക്കെ ഉണ്ടല്ലോ,
അതെ,
അത് സ്യൂഡോസ്ഫെറിക്കൽ എന്ന് പറയാൻ പറ്റുമോ?
അത് ലോഡില്ലല്ലോ. അവിടെ ഫൈബർ ഡയറക്ഷൻ ഇങ്ങനെ പോയാലേ സ്യൂഡോസ്ഫെറിക്കൽ ആവത്തുള്ളൂ. അല്ലെങ്കിൽ ഷേപ്പ് മാത്രമേ ഉള്ളൂ. സ്പെറിക്കൽ എന്നുള്ള വാക്കിന് അർത്ഥമില്ല. സ്പെറിക്കൽ മീൻ മെമ്പറൈനുള്ളിൽ, നോ ബെൻഡിങ്. അത് ഈ കൂളിംഗ് ടവറിന് ഇത് ബെറ്റർ ദാൻ കോൺ. ബെറ്റർ, കോണിനെക്കാട്ടി ബെറ്റർ ആണ്.
ക്ലാസ് കഴിഞ്ഞു.
നിങ്ങൾ എന്തോ കാണിക്കാന്ന് പറഞ്ഞു സ്റ്റുഡൻസ് പറഞ്ഞു. മറ്റേ ഓപ്പൺ ആവുന്നില്ല അല്ലേ ഒരു ഫയൽ? എനിക്ക് ഓപ്പൺ ആവില്ല. എന്തോ പറയാം, എൻ്റെ അഡോബ് എന്തോ പറഞ്ഞു, അഡോബ്ന്നോ? നോക്കാൻ പറ്റുമോ? ഇല്ലല്ലോ.
Thank you, Ramesh sir, for giving insights into the composite theory, especially classical laminate theory. I believe you could able to understand that there is a difference between isotropic material and composite material. And yeah, see the application, you can actually get it from different, available in internet. But if you want to study the theory aspects, like what's Young's modulus, what's Poisson's ratio, so he explained about Poisson's effect and all. So that thing can only be available through this lecture series only. So for second year MTech, first year MTech students, you come back at 2 o'clock. We'll have a small demonstration of vacuum pressure vessel, vacuum mold composite manufacturing technique for a laminate. We purchase laminate also. So that we will demonstrate at 2 o'clock. So now Now I invite HOD Sir Madhyan Sir to give a token of gratitude to Ramesh Kumar Sir and to say a few words.
So it is a pleasure for me to be here with the Dr. Professor Ramesh Kumar R. And he has spoken about the composite mechanics. And this topic is very relevant as far as the structural, parts are concerned, as far as the department is also concerned. And most of the students have learned about the software or the FEM or maybe other related softwares. You can apply the FEM software to design any models or any design so that it will be a new product, innovative product, and that would be useful for the society. Okay. So thank you, sir, for having come over here and presented your expertise, knowledge for our students, and will.
It will be useful for the design of ship
It
related.
is also useful.
It will not have rusting and all that.
Boat building, particularly in the boat building industries.
Boat building, it's already established. It may be available, but you can try that.
Yeah. So maybe, and also there is a 3D printing. Okay, so you can use a composite for 3D printing. Some of the components, some of the small articles can be made by composite itself. For that, we have to make one design. Based on this design, you have to make a 3D objects. 3D facilities available in our university itself. 3D printing is available. I think most of you are aware of this. Models, models can be made, or any structural models can be made in a pilot scale or the prototype models can be made using a composite materials. Composite is a versatile material; it can be used for any applications because it is having so many properties. No corrosion. Corrosion is one of the things that is taken care of by these composite materials. Only problem with composite is when it is used in water, the water absorption. Water absorption is the main problem.
And people put painting.
Yeah, you can apply painting.
Or even, okay, water absorption, there will be some swelling will be there.
Swelling will be there.
The initial phase.
Delamination will be there. Okay, so those problems would be addressed. Okay, and that can be solved by applying some coating. Okay, anti-fouling coating. If suppose you want to use the material, that composite material for boat building,
what happens in the people will put other sacrificial layer of metal in the outside. After some time that you can remove and put sacrificial layers also.
Yeah, but that is used for metal only.
Correct, and that's what I'm saying. No, in the composite body, use a sacrificial metallic film.
Okay. Yes.
So that once it corrosion, remove it and put another one like that.
Okay.
So the load-bearing member will remain there.
Sandwich part.
But how to combine composite with the metal?
Bonding only. Glued, and if you want for reliability, see, sacrificial layer, if it goes also, you don't have to really bother. That will be a layer put, and if it goes also, no problem. Glue it, and if it goes also, you can put. The main load-bearing member should not get affected.
So what is the recent developments in composite materials? What type of
composite? We have this rocket launching, sandwich structures. Carbon is there for re-entry vehicles. The temperature goes up to 2500 degrees centigrade. So what happened? I tell you a story which we faced in VSSA for 10 years, before 2008. What happened? They were trying to make a reusable launch vehicle purpose. During re-entry condition, they are not able to make. So whatever they tried is failing. So what they did, like nowadays, chapatis, half-cooked chapatis are there. Like that, they did not they did not cure the skin. They just put. So at the time of re-entry, it is getting cured. So it takes some time. So the trajectory will take some half an hour, means some 15-20 minutes. It will go for the curing of it. Then it will become carbon. Then it is like that they are able to make it. Survived like that. If you make carbon and put it in the beginning itself, it will goes off. Because it will become red hot and then erode. So instead, they put it the kacha.
So the
So when they
resin of the hardener will be separated.
no, that carbon, this thing, not cured fully, semi-cured thing. So that you can handle it and assemble everything while returning in the re-entry time, due to the heat, it will get cured. So that some time can be saved. Duration, suppose the duration is 30 minutes. This will take 10 minutes. So you have to cater for 20 minutes only. Otherwise, total 30 minutes you have to cater. This structure will be.
So some of you can take up projects in this area also. For MTech students, you are really interested in taking up some projects. Okay, you can take this topic as your MTech project. Because there is a scope of this topic. You can go and work some.
You have that
companies.
facility now available.
Composite
Composite product.
make a model and go for a finite element analysis.
We have
that is also
we purchase vacuum pump. In our department, we have vacuum pump and all the facilities. So if you want to make laminate from laminate, we have vacuum pump facility and vacuum bag. We will create and we can make composite.
So do one thing that you take up one materials, particularly this composite materials, and plan a design. Some whatever you want to take a design of models, any models for structural applications. Okay, you have mold, then you go for curing the materials. After curing, go for the mechanical testings. That testing is available in the polymer science department. So you can do the mechanical testing and then go for a FEM analysis. That will be a great project. And you can submit the pattern also. Because the number of patterns which we are getting is very less. Very less. People are not going for patenting. Suppose you have some innovative idea. Okay, if you have some innovative idea, you can develop. How will you develop an innovative idea? You have any idea? What is innovation? What do you mean by innovation? What is idea? How the ideas are generated? Huh? Real-time problem. How do you create? How do you get the problems? How do you get the idea? Real world scenarios. Okay. Ideas are there everywhere. Ideas are there everywhere. Your discomfort, your limitation, drawback, okay, disadvantages. From there only you get the ideas. Clear. If there is a disadvantage, for example, the Ola car or the Uber, okay, it's an idea. Idea is not only the product, it is a concept. How the idea of the Uber came to world. People had difficulties in traveling, right? So that difficulty gave them idea. So wherever you find the difficulty, discomfort, okay, limitations, shortages, shortcomings, okay, there you have to apply your mind. You have to find out what is the reason for that. Okay, and then develop your idea. Idea is nothing but connecting dots. Okay, connecting dots. If you connect two ideas, you get a new idea. Okay, that is how you have to create innovative ideas. Okay, so in future, the job market is very limited. You cannot get a job unless you go for some kind of startup or entrepreneurs or some company owners or CEOs. Okay, You cannot get a opportunity like this. Okay. So you have to focus on this also, not only the job market. You have to not only depend on the job market, but also creating your own business. For that only ideas. You have to create ideas. There are n number of opportunities available, but you have to approach, your mindset, your attitude. That only matters. Okay. So go for different types of projects, different types of the idea creations. We can have an idea session itself. How to create an idea. How to create an idea. That's also possible. What do you think? No, you are thinking something. Okay. What is thinking? What do you mean by thinking? Huh? Thoughts and thinking are different. Thoughts and thinking are different. There are two entities. Thinking is present, thought is past. Okay. So without anything, you cannot think. So there should be a canvas on which you are drawing something. No. Similarly, there should be a medium on which, okay, you have to think. Right? You take one topic and about that topic, you ask questions. That is thinking. Ask question. Suppose Sir has taken class now. About the topic, you ask questions yourself. Okay, then you will get the new ideas. Okay. We'll have another session if possible. Okay, thank you.
Now we invite Madian sir to give a certificate and mementos. Certificates, sir. We are giving sir one cloth layer. I mean, not one, more than one cloth layers of glass fiber. That will also be given us. Yes.